Students, welcome to the today's lecture. So today's lecture we are going to discuss about moment of inertia of a rectangular lamina. So in our last class we discussed about flywheel, right, and its applications. So today in our class we are going to discuss about moment of inertia of a rectangular lamina. So here moment of inertia of rectangular lamina. Right? So here moment of inertia of rectangular lamina. Moment of inertia of rectangular lamina, right? So here what happens, now we are going to consider rectangular lamina, right? Here the length is what? B. The breadth is B. Right. Then I am going to take axis. Right. So this is x, this is y, this is y. Right. This is y, this is y. So this is center of mass. This is center of mass. Right. Now I am going to consider here so from here to here the distance is y. From here to here the distance is y. So this small is what? dy. Small is what? dy. Right. So here what happens? See, if this completely d means this becomes how much? D by 2. This becomes how much? D by 2. This is also d by 2. This is also d by 2. This is also d by 2. Right. So this is means this is b by 2. This is b by 2. Right. And this one I am going to take AB, CD, AB, CD. Alright. So here consider a rectangular lamina to find out moment of inertia. Find out moment of inertia. And length and breadth of lamina is D and B. D and B. Right. D and B. So now here, now I am going to take, see, here this is a small elementary slip. DA, ಇದು ಒಂದು ಏರಿಯಾ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ರೈಟ್? ಈ ಏರಿಯಾ ಸ್ಮಾಲ್ ಎಲಿಮೆಂಟರಿ ಸ್ಲಿಪ್ ಇದೆ. ಈ ಸ್ಮಾಲ್ ಎಲಿಮೆಂಟರಿ ಸ್ಲಿಪ್ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ನಾವೇನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ? ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ, ರೈಟ್? ಸೊ ಹಿಯರ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ ನೌ area of a small elementary slip. So small elementary slip. Small area can I consider DA? So DA ಅಂತ consider ಮಾಡಬಹುದು, right? So DA means here, see, in which axis it is? Y axis. So then y, how much it is? dy. Call equation number. Call equation number. Equation number 1. Call equation number 1. Right. So then, here, moment of inertia of elementary slip. Moment of inertia of elementary slip. No, moment of inertia of elementary slip. Moment of inertia of elementary slip. Right? So here that becomes y square into d. Y square into d. Note. Moment of inertia ಗೊತ್ತಿದೆ ನಮಗೆ. ಏನು moment of inertia ಇದೆ? m r square. Clear ಇದೆ? m r square ಅಂದ್ರೆ r ಅಂದ್ರೆ ಡಿಸ್ಟೆನ್ಸ್. ಅದರ ಯಾವಾಗಲೂ ನಾವು ಸ್ಕ್ವೇರ್ ಮಾಡ್ತೀವಿ. m ಅಂದ್ರೆ ಮಾಸ್. ಇಲ್ಲಿ d ಅಂದ್ರೆ ನಮಗೆ ಮಾಸ್ ಇದೆ. ಕ್ಲಿಯರ್ ಇದೆ? ಸೊ ಇಲ್ಲಿ y ಅಂದ್ರೆ ಈ ಡಿಸ್ಟೆನ್ಸ್. y ಅಂದ್ರೆ ಈ ಡಿಸ್ಟೆನ್ಸ್. ಯಾವಾಗಲೂ ಗೊತ್ತಿದೆ ನಮಗೆ moment of inertia ಹೆಂಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ ಅಂತ ಗೊತ್ತಿದೆ ನಮಗೆ. ಇದು ಒಂದು ಸಪೋಸ್ ರಿಜಿಡ್ ಬಾಡಿ ಇದು ಏನು ಇದು about an axis. ಇಲ್ಲಿ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಾಕಿದ್ರೆ ಎಷ್ಟು r is a mass of the medium r square. ಹಂಗ ಏನೈತಿ y square dA. Y square dA ಗೊತ್ತಿರಬೇಕು. Right. So then y square dA ಆಗೈತಿ. Now I am going to take, see here, y square. What is dA? Y into dy. Y into dy. Sorry. B. There is a small mistake here. B into dy. B into dy. So then it becomes B into dy. B into how much? dy. So y square B dy. Right. Now we will take moment of inertia of rectangular lamina. Moment of inertia of rectangular lamina. So moment of inertia of rectangular lamina. Moment of inertia of rectangular lamina about x axis. About x axis. Alright. ಇದು x axis ಇದು x axis. x axis ನ ಏನು ಮಾಡ್ತೀನಿ? Moment of inertia ಏನು ಮಾಡ್ತೀನಿ? Find out ಮಾಡ್ತೀನಿ. Right. So moment of inertia is denoted by Ixx is equal to see here integration of ನೋಡ್ರಿ integration of ನ ಏನು ಬರಿಬಹುದು? integration of ಏನು ಬರಿಬಹುದು ನೋಡ್ರಿ. see here x to x ಕೊಡಾಗಿದೆ see x y x ಏನಿರ್ತದೆ ಪಾಸಿಟಿವ್ ಇದೇನಿರ್ತದೆ ನೆಗೆಟಿವ್ ಇದೇನಿರ್ತದೆ ಪಾಸಿಟಿವ್ ಇದೇನಿರ್ತದೆ ನೆಗೆಟಿವ್ plus minus getting my point. So now I am going to take, see this is the value of x, this is also same d by 2. So minus d by 2 to plus d by 2 minus d by 2 plus d by 2. So what is the moment of inertia? ಇದನ್ನ ನಾವು ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ನಮಗೆ ಪೂರ್ತಿ ಸಿಗ್ತೈತಿ. ಎಷ್ಟು ನೋಡ್ರಿ b y square dy b y square dy b y square dy. Getting your point? Right. Now see here once again x axis is equal to b common ತೆಗಿತೀನಿ. once again b constant ತೆಗಿತೀನಿ ನಾನು minus d by 2 plus d by 2. So once again what becomes b square dy. Sorry, y square dy. Right. So now it becomes ಏನಾಗ್ತಿದೆ ನೋಡ್ರಿ. So next here Ixx is equal to ixx is equal to b. So integration of y square ಏನಾಗುತ್ತೆ ನೋಡಿ y cube divided by 2. So plus d by 2 minus d by 2 plus d by 2 minus d by 2, right? Next here once again is equal to b ಎಷ್ಟಾಗುತ್ತೆ ಅಪ್ಲೈ ಮಾಡಿ d by 2 upper limit lower limit apply ಮಾಡಿ d cube divided by ಎಷ್ಟಾಗುತ್ತೆ ನೋಡ್ರಿ 24 plus d cube divided by 24 plus d cube divided by 24, right? So once again it becomes b d cube take a common, right? Divided by how much? 24. Divided by how much? 24. Sorry. One ಕೆಲಸ ಮಾಡ್ತೀನಿ. So do one thing here. B is equal to 2d cube divided by 24. Getting my point? So 2 ones are 2 12s are 2 ones are 2 12s are. So then it becomes b d cube divided by 12. b d cube divided by 12, right? So here I x is equal to b d cube divided by 12. I x is equal to b d cube divided by 12. Right? So then moment of inertia about AB axis. Moment of inertia of AB axis. So IAB is equal to so IAB is equal to how much? So use parallel axis theorem here, parallel axis theorem apply ಮಾಡಿರಲಿ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ parallel axis theorem apply ಮಾಡಿ ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ IXX plus a d by 2 whole square right? d by 2 whole square. So then what is our IXX? How much it is? BD cube divided by 12 plus a d by 2 square. ಏನಾಗ್ತಿದೆ ನೋಡ್ರಿ So here area is equal to length and breadth. So length and breadth are b into d. So d by 2 square andre d square divided by 4. Right? So now here what happens? B, right? D cube divided by 12 plus BD. D square ಏನಾಗುತ್ತೆ ಕ್ಯೂಬ್ ಆಗುತ್ತೆ BD cube divided by 4 right? So once again it becomes how much? Is equal to IAB is equal to how much? 12, right? 12 ones are 4 3s are, right? So BD cube plus 3BD cube. So then IAB is equal to 3 plus 1 4BD cube divided by 12. 4 ones are 4 3s are, right? So BD cube divided by 3, right? So similarly IYY is equal to ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ IYY is equal to similarly same ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ BD cube divided rectangular laminar. So ಅದು ನಮಗೆ ಏನಾಗ್ತೈತಿ rectangular laminar ಏನಾಗ್ತೈತಿ inertia, right? So here next one, that is once again moment of inertia of a thin rod. Moment of inertia of a thin rod. Moment of inertia of thin rod. Moment of inertia of a thin uniform rod. Moment of inertia of a uniform thin rod. A uniform thin rod. Right. Moment of inertia of a uniform thin rod. Uniform thin rod. Right. So here now we are going to consider uniform thin rod here, uniform thin rod here. So this is an axis, right? About an axis, about axis, right? So here moment of inertia at center, moment of inertia at center, right? So the total length is L. Total length is L. So half means when we are going to half means this is plus L by 2, but if we are going to take the axis it becomes what? Plus minus. So this is minus L by 2, right? So here I am going to consider a small amount of mass here. A small amount of mass. So that is dm. Small amount of mass dm, that is having the distance from this axis r. So ಅದೇನಾಗ್ತೈತಿ r distance ಐತಿ, and so here this is very small means it is taken as what? dr. It is taken as what? dr, right? So here about an axis passing through, about an axis passing through, about an axis passing through center of mass and perpendicular to its length. Passing through center of mass and perpendicular to its length. Passing through center of mass and perpendicular to its length. Right. So then here m is mass of the rod. M is mass of the rod. L is length of the rod. L is length of the rod. dm is mass of small element of rod. dm is small mass element of rod. Small mass element of rod. dr thickness or width of small element. So then C is what? Center of mass. C is center of mass, right? So here IC, moment of inertia of center of mass. Moment of inertia of center of mass. Moment of inertia of center of mass, right? So I am going to take another one here, that is sigma. That sigma is what? Uniform density. Uniform density. That uniform density is equal to mass by length. Mass by length. So density ಅಂದ್ರೆ mass by length ಅಂತ ಏನು ಮಾಡ್ತೀವಿ ಹೇಳ್ತೀವಿ. Also sigma is equal to dm by dr. Also sigma is equal to dm divided by dr. So mass by length ಇದು thickness. ಅದನ್ನ dr ಅಂದ್ರೆ thickness ಅಥವಾ width ಅಂತ ಆಯ್ತು. dr here dm is equal to sigma into dr. तो बदलना है dm is equal to sigma into dr, right? dm is equal to sigma into dr. ಇಲ್ಲ ಇನ್ನೊಂದು ಈಕ್ವೇಷನ್ ಇದೆ, ಏನಂತ ಬರೀತೀವಿ ನಾವು? dm is equal to right? dm is equal to ಏನಂತ once again same sigma into dr, right? So can we put the sigma is equal to m by l dr by m by l dr, right? So now for mass dm what? I is equal to ಏನಂತ ನೋಡ್ರಿ, for mass dm I is equal to what? R square into dm. I is equal to what? R square into dm. See here what happens. That version I get small amount of mass I think. How much it is having the distance? R into, right? So what is our moment of inertia? Moment of inertia is the product of mass into what? The square of the distance between mass and that axis, right? So then distance is how much? R square. So then this is the mass, small amount of mass. So this is what? R square dm. Now see, for rod of mass m, which is made up of, for rod of mass m which is made up of small masses dm. Small masses dm. ಹೌದ್ರಿ. ಸೊ ರಾಡ್ ಒಳಗ ಮಾಸ್ ಇರ್ತೈತಿ. ಸೊ ಸಣ್ಣ ಪಾರ್ಟಿಕಲ್ ಸಣ್ಣ ಮಾಸ್ ಪಾರ್ಟಿಕಲ್ ಕೂಡಿ ಏನಾಗಿರ್ತೈತಿ? ಸೊ ದೊಡ್ಡ ಮಾಸ್ ಆಗಿರ್ತೈತಿ. ಗೊತ್ತಾಗಿರ್ತೈತಿ. From minus L by 2 plus L by 2. From minus L by 2 to plus L by 2. Minus L by 2 ಇಂದ plus L by 2 ತನಕ ಎಷ್ಟು ಟೋಟಲ್ ಮಾಸ್ ಸಿಗುತ್ತೆ? It is my point. So we can write so I is equal to integration of minus L by 2 to plus L by 2. Minus L by 2 to plus L by 2. So then IC ಅಂತ ಬರೋದು IC is into what? I. So then now I am going to substitute the value of I here. Minus I value put ಮಾಡಿ right. So once again ಏನಾಗ್ತಿದೆ ನೋಡಿ here can I write IC is equal to moment of inertia at the center of mass is equal to minus L by 2 plus L by 2 minus L by 2 plus L by 2 R square dm is our dm. Can I write dm is equal to ml divided by dr m divided by L into dr ಬರಿಬಹುದು ನೋಡ್ರಿ ಈಗ right ಬರಿಬಹುದು. So then here what happened means IC is equal to m divided by L, take as a constant m divided by L, taking as a constant. So minus 2 plus minus L by 2 plus L by 2 what R square dr. Now integrating one by one IC is equal to m divided by L. So then it becomes R cube divided by 2. It becomes how much? Sorry, R cube divided by 3. When it is integrated, so then it becomes R cube divided by 3. So then once again what? Plus L by 2 minus L by 2. Integrated ಮಾಡಿ. So then it becomes m divided by m IC is equal to once again m divided by 3L. M divided by 3L. So then now put the value of upper limit and lower limit. Put the value of upper limit and lower limit. So then it becomes L cube divided by 8. L cube divided by 8 minus L cube minus of minus L cube divided by 8 minus of minus L cube divided by 8. So then it becomes, see here m divided by 3L, m divided by 3L. So then L cube divided by 8 minus into minus plus L cube divided by 8. L cube divided by 8. Right? So then here IC is equal to once again. IC is equal to once again. How much it becomes? See, m divided by 3L. So L cube plus L cube 2L cube divided by 8 divided by 8. Right? 2 1s are 2 4s are 2 1s are 2 4s are. So then IC is equal to m divided by this cell 1L. Right? So only 3 remains here. M L square. M L square divided by 3 into 4. Right? So IC is equal to m L square divided by m L square divided by 12. Right? So this is the center of mass. This is the center. Sorry, what? This is moment of inertia of a uniform thin rod. So minus L2. ಎಲ್ಲ ಕಡೆ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. ನಾ ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಇಷ್ಟು ಸ್ಮಾಲ್ ಪಾರ್ಟಿಕಲ್ ಟೋಟಲ್ ಮಾಸ್ ಪಾರ್ಟಿಕಲ್ ಎಷ್ಟಾಗುತ್ತೆ? You have to integrate. You have to what? Integrate. Right? So this is moment of inertia of a uniform thin rod. Moment of inertia of a uniform thin rod. Right? Moment of inertia of a uniform thin rod. Right? So for small mass ತಗೊಂಡಾಗ ಈ ರೀತಿ ಆಯ್ತು. So then small mass ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ r ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟೈತೆ ಮಾಸ್ dm into r ಸ್ಕ್ವೇರ್. ರೈಟ್? ಸೊ ಸ್ಮಾಲ್ ಮಾಸ್. ಸೊ ಇಂಟಿಗ್ರೇಟೆಡ್ ಆ ಮಾಸ್ ಅನ್ನು ಇಂಟಿಗ್ರೇಟೆಡ್ ಮಾಡಿದಾಗ ಟೋಟಲ್ ಮಾಸ್ ಸಿಗ್ತೈತಿ. ಎಲ್ಲಿಂದ ಇರ್ತಾನೆ? minus L by 2 plus L by 2. minus L by 2 ಇಲ್ಲಿ plus L by 2 ಇಲ್ಲಿ. It is point. Right? So this is. So here next another one derivation is that is moment of inertia of a circular disc. Moment of inertia of a circular disc. That is going to discuss in our next class. Right?